Part 1. In the beginning, it seemed like just another night in the long, patient watch of the cosmos. Telescopes pivoted silently across the black canopy, tracking points of faint light that drifted through eternity. Among these glimmers was one that drew almost no attention, a small unassuming object catalogued under a provisional name, 3 Atlas. It was thought to be a simple fragment of primordial ice and rock, a relic from the time before planets were born. Astronomers, ever fond of order, placed it neatly among the countless icy wanderers that haunt the outer reaches of our solar system. Its orbit was clear, its trajectory predictable, its presence almost poetic in its insignificance. Yet, as we would soon learn, even the quietest objects in the heavens can hold the loudest secrets. The story begins not with chaos, but with certainty. For months, observatories across the world, from Mauna Kea to La Palma, from Chile's Atacama Desert to the silent cold of Antarctica, followed Atlas as it made its slow descent toward the inner solar system. The data was consistent, its numbers precise. Astronomers smiled at how elegantly it obeyed Newton's laws, how neatly the predictions fit the reality. There is a particular comfort in such obedience, a reminder that the cosmos, though vast and unknowable, still plays by rules we can understand. But certainty is fragile, and the universe has a habit of breaking its own silence in the most unexpected ways. It happened on a clear October night. Mars shimmered faintly on the horizon, a red ember glowing in the cosmic dark. And then, with no warning, Atlas broke the script. Telescopes registered a sudden flare, a surge of light so precise and focused that for a moment many believed it to be an instrument glitch. But as the data repeated and the images from distant observatories began to align, disbelief turned to awe. From the surface of Atlas, a narrow beam of light erupted, sharp, coherent, impossibly steady. It was not scattered sunlight, nor a burst of sublimating gas. It was a beam, clean and deliberate, locking onto Mars like a mechanical eye opening after eons of sleep. The light did not waver. It did not pulse randomly or fade with the usual chaos of natural reflection. It held, steady, focused, unwavering, as if guided by purpose. Across millions of kilometers, it reached toward the red planet with an intent that no equation could describe. For the first time, humanity saw not a reflection of starlight, but what looked like the act of illumination itself. A whisper from the void had become a scream. For generations, comets have been the obedient children of gravity, their orbits carved by the invisible hands of celestial mechanics. Give a scientist enough data, and they can map their paths for centuries. But 3 Atlas broke that sacred trust. Its light curve began to twist into chaos, surging when it should have dimmed, darkening when the models demanded brilliance. At first, the errors were dismissed, perhaps a software glitch or interference from solar activity. But as confirmations poured in from across the globe, the pattern held. The object was changing in ways that defied every known principle. The light curve, the very heartbeat of a comet, began to pulse like something alive. The rhythm was too deliberate to ignore, as if the object was responding to unseen stimuli, or perhaps communicating through the only medium the universe truly understands, light. Each flare coincided with a planetary alignment, each silence with the passing of Mars through its field of view. Coincidence, perhaps, but then again, nature rarely writes coincidences in such perfect rhythm. And so, as scientists scrambled to interpret the impossible, one haunting question began to emerge. Could this be more than a mere comet? Could we be witnessing not a natural phenomenon, but a construct, something ancient, something designed? The suggestion was almost heretical. Yet in the face of data that refused to obey physics, heresy was beginning to sound like reason. In the dark of that October night, when the beam first struck out toward Mars, the universe changed. For the first time, the cosmos seemed to look back. Part 2. In the weeks that followed that October night, the world of astronomy entered a state of organized disbelief. What began as a rumor, whispered among late-night observatories, soon became the most scrutinized cosmic event in living memory. 3i Atlas, once considered a routine cometary body, had done something that no celestial object had ever done before. It had produced a coherent, sustained beam of light directed with surgical precision toward Mars, and the implications of that act rippled outward like shockwaves through every discipline of science. At first, the explanations were cautious. The European Southern Observatory suggested an unknown photochemical reaction within the comet's crust, perhaps triggered by volatile ices. NASA proposed that an unusual configuration of reflective crystals might have created an optical illusion, a perfectly aligned glint. But none of these theories could survive the weight of continued observation. The beam was not a flicker. It persisted for almost 11 full minutes, maintaining alignment with a variance of less than 1/10 of a degree. A precision far beyond any natural process known to planetary science. In physics, light that coherent is called monochromatic, and such beams are usually born only in laboratories or within the disciplined architecture of technology. As telescopes around the planet continued to study Atlas, more peculiarities emerged. The object's brightness began to oscillate in rhythmic cycles, each pulse occurring with uncanny regularity, precisely every 39 hours. The pattern held steady across all observation platforms, unaffected by atmospheric interference or solar activity. When the signal was converted into a waveform and analyzed through Fourier transformation, the output revealed harmonic substructures, layered frequencies that bore the mathematical signature of order, not chaos. It was as if the object were transmitting in code, using light itself as the carrier. Radio observatories, from the Allen Telescope Array in California to the deep dishes of Australia's Parkes facility, turned their ears toward Atlas. For weeks they listened, sweeping the electromagnetic spectrum from kilohertz to gigahertz. But the silence was absolute. No radio emissions, no microwaves, nothing but the eerie precision of visible light. That silence itself spoke volumes. If Atlas was communicating, it was doing so in a form of language humanity had never used before, perhaps a language that needed no sound at all. Spectroscopic analysis soon deepened the mystery. When scientists broke down the beam into its constituent wavelengths, they found patterns that should not exist. The emission lines showed minute but repeating deviations from known atomic transitions, narrow bands where light seemed to carry information, modulated not randomly but algorithmically. A comparison with the solar spectrum revealed that the beam had absorbed and re-emitted photons in discrete intervals, each corresponding to ratios of prime numbers. Prime sequences are not the creation of natural physics. They are artifacts of intelligence. As this data circulated, debates ignited within the halls of the world's leading institutions. At the Max Planck Institute in Germany, researchers cautiously suggested that the beam might represent a new category of coherent photonic emission, a naturally occurring laser produced by extreme crystalline alignment within the comet's internal matrix. Others dismissed this as wishful thinking. The temperatures required for such precision could not exist within an icy nucleus drifting hundreds of millions of kilometers from the Sun. Still, the Institute's findings hinted at an uncomfortable possibility, that Atlas was not composed of ordinary matter at all. When the James Webb Space Telescope turned its golden mirrors toward the anomaly, the resulting infrared data revealed something unprecedented. The thermal profile of Atlas did not match its optical brightness. It was far too cold. In space, brightness and temperature are married. An object that shines must emit heat in proportion to its light. Yet Atlas glowed brilliantly without radiating the expected thermal energy. This contradiction is one of the hallmarks of artificial luminescence. Light produced not by combustion or reflection, but by controlled emission, perhaps through engineered photonic structures. Then came the chemical enigma. Mass spectrometry from the Atacama Large Millimeter Array detected molecular compositions utterly foreign to known comets. Instead of water vapor, which dominates ordinary comet tails, Atlas's atmosphere was dominated by carbon dioxide and carbon monoxide in almost perfect equilibrium. This ratio is thermodynamically unstable. It should not persist in open space. To maintain such balance implies active regulation, as though the comet were sustaining itself through chemical feedback, adjusting composition the way a machine might control temperature. Further, anomalies appeared in the metallic readings. Nickel was present in abundance, but its twin element, iron, was strangely absent. Throughout the cosmos, nickel and iron are inseparable, formed together in stellar forges. To find one without the other was like discovering a heartbeat without blood. Metallurgists analyzed the spectral data and noted that the purity of the nickel lines was extraordinary, beyond what natural processes could refine. On Earth, such separation requires industrial smelting. In space, it should be impossible. As data accumulated, one hypothesis began to take shape. Whispered at first, then spoken aloud. Atlas might not be a comet at all. It could be an artifact, a relic of technology adrift for eons, disguised beneath the shell of ancient ice and dust. To even suggest such a thing was heresy, but the evidence refused to yield. Dr. Elara Vos, a senior astrophysicist at the European Space Agency, presented a paper titled Non-Natural Photonic Phenomena in Near-Solar Objects. In it, she argued that Atlas exhibited all the hallmarks of a controlled energy emission system. She proposed that the beam directed toward Mars was not a random act, but a targeting event, a deliberate attempt to focus energy on a planetary surface, perhaps as communication or calibration. She calculated the beam's power output to be equivalent to several hundred megawatts, enough to illuminate an entire city. Its coherence over millions of kilometers suggested structural confinement, a focusing mechanism, maybe even a lens or aperture hidden within the comet's body. Simultaneously, the Harvard-Smithsonian Center for Astrophysics began re-examining historical comet data for precedents. They found none. No recorded comet, asteroid, or interstellar visitor had ever displayed sustained emission at a single wavelength, nor such geometric precision. Even Oumuamua, the interstellar traveler of 2017, had merely reflected sunlight. It had never produced its own. Yet in comparing orbital paths, a strange resonance emerged. Atlas's entry vector matched Oumuamua's trajectory within a fraction of a degree, as though both had originated from the same distant region beyond the Orion Arm. The question now turned from how to why. Why would such an object focus its attention on Mars and not Earth? Some speculated that Mars, being lifeless on the surface but home to our robotic explorers, was a safer recipient, a proving ground, a test of observation. The Mars Reconnaissance Orbiter detected minute fluctuations in its sensor arrays coinciding with the beam's arrival, as though subtle bursts of energy had brushed against its instruments. Nothing destructive, nothing invasive, merely contact. If this was communication, it was cautious, measured, deliberate. Meanwhile, the color transformations of Atlas baffled planetary chemists. The sudden shift from deep crimson to vivid emerald could not be explained by solar heating, as it occurred at temperatures too low for carbon activation. Instead, the transition followed orbital geometry. Every time Mars approached conjunction with Atlas's line of sight, the hue shifted precisely 243 nanometers toward the green spectrum. Spectrographs revealed controlled emission peaks at wavelengths used in terrestrial laser communication systems. It was as though the comet were modulating color intentionally, transmitting across the visible spectrum in a form of photonic Morse code. Some researchers proposed that The changes were part of a sequence, a visual algorithm that repeated in cycles of 3. The intervals corresponded to Fibonacci ratios, patterns deeply embedded in both nature and human mathematics. Was this coincidence, or was the universe using a language we were finally ready to perceive? Then came the most disturbing revelation. As Atlas approached the sun, its behavior defied every law of celestial mechanics. Instead of its tail streaming away from solar radiation, the luminous beam turned toward the sun, pointing directly into the star's heart. Anti-tails, though known, are weak and transient illusions caused by perspective. This was different. The beam was coherent, sharp, unwavering, and perfectly aligned with solar longitude. It extended millions of kilometers, visible even through coronagraphic filters. It was as if Atlas was drawing power from the sun rather than fleeing it. Astrophysicists began to model the energy transfer. If the beam was acting as propulsion, it could, in theory, allow Atlas to maneuver independently of gravity. And indeed, minor deviations in its orbit soon appeared, subtle, but real. The comet was adjusting its course, as if guided. To achieve such control, its interior would require energy sources orders of magnitude beyond anything humanity had yet constructed. In laboratories from Geneva to Tokyo, physicists stared at the data and found themselves whispering a single word: impossible. Yet impossibility, they knew, was merely a measure of how far understanding still had to travel. By December, a consensus of sorts emerged among the boldest voices in astrophysics. Atlas was either the most extraordinary natural object ever discovered or the first confirmed artifact of extraterrestrial technology. There was no comfortable middle ground left. The evidence pointed in directions that reason itself hesitated to follow. If it was natural, it would rewrite chemistry, optics, and thermodynamics. If it was artificial, it would rewrite humanity's place in the cosmos. As debates intensified, a sense of awe settled over the global scientific community. Observatories that once competed now shared data in real time. Nations suspended proprietary claims over telescope time, uniting instead under a single purpose: to understand. The night sky had become a message board, and Atlas was its lone author. For centuries, humanity had searched for signs of life beyond Earth. We listened for radio transmissions, probed exoplanets, and scanned the cosmic microwave background for anomalies. Yet perhaps we had been listening to the wrong language. Light, the oldest messenger in the universe, had always been speaking. We had simply not known how to listen. And so, as the year drew to a close, telescopes continued to trace Atlas's movement as it slipped behind the sun, entering that brief period of invisibility known as solar conjunction. For several weeks, the object would be hidden from view, shielded by the star's blinding radiance. Scientists waited anxiously, instruments poised, breath held. Because when it emerged again, whatever it revealed, or whatever it chose to do next, would decide whether 3A Atlas was a natural wonder or the first emissary of an intelligence older than humanity itself. Part 3. When 3A Atlas finally re-emerged from behind the sun, the world's instruments turned toward it as if toward revelation. The silence that had followed its disappearance was heavy, like the pause between heartbeats. But what returned from that blinding curtain was not merely data. It was the beginning of a new chapter in humanity's understanding of its own smallness. Atlas came back brighter than before, its beam dormant now, its colors muted, as though the act of its illumination had spent some vast internal reserve of energy. Yet the quietness of its reappearance carried more weight than its earlier spectacle, for silence can speak when the cosmos chooses to hold its breath. Among those waiting for its return was a name already whispered through the corridors of modern astrophysics: Dr. Avi Loeb. Years earlier, he had proposed that Oumuamua might have been an interstellar craft, a suggestion dismissed by many as poetic speculation. But with Atlas, Loeb's caution turned into measured conviction. His models of non-gravitational acceleration, his theories of light-driven propulsion, and his insistence that the universe could harbor technological debris, all now found a strange echo in the reality unfolding above. Loeb became one of the principal voices leading the renewed investigation. His laboratory at Harvard transformed into a war room of quiet obsession. Data streams from global observatories converged upon his servers, and his team began mapping the object's motion in microscopic detail. It was Loeb who first noticed the pattern hidden in Atlas's orbital path. The object's periodic bursts of brightness, its erratic yet consistent maneuvers, and its synchronized alignments with Mars all seemed to follow an elegant geometry. Not random, but relational, as if responding to celestial harmonics. When the orbital resonance was charted in 3 dimensions, the trajectory formed a repeating lattice, a helical braid weaving through the ecliptic plane. No known natural mechanism could produce such precision. To Loeb, the evidence suggested intentionality, perhaps a navigational algorithm encoded into motion itself. He called it the choreography of purpose. The question of its structure remained. What lay beneath the crust of this cosmic wanderer? Radar studies hinted at density irregularities, dense metallic veins intertwined with hollow regions that behaved like cavities or conduits. These internal voids resonated faintly when struck by solar wind, creating vibrations detectable as low-frequency oscillations. Some described them as the breathing of a machine asleep. The patterns were regular, not seismic, not random. Deep within the frozen nucleus, something was structured. Engineered, perhaps, a lattice of ordered cavities, each reflecting energy like mirrors arranged with mathematical precision. Meanwhile, the Mars Reconnaissance Orbiter prepared for its historic observation. On October 4, 2025, the orbiter's high-rise camera would capture Atlas from the vantage point of another world. Engineers adjusted calibration tables, running simulations to ensure that no fragment of data would be lost. Across the globe, in silent anticipation, humanity prepared to see an object not from Earth, not illuminated by our sun from our perspective, but seen as Mars would see it, from the other side of the story. When the day arrived, Mars turned its gaze toward the visitor. The images came slowly, transmitted across millions of kilometers, pixel by pixel, each bit a whisper of revelation. And there, amid the blur of cosmic dust, Atlas appeared. Sharp, crystalline, impossible. The photos revealed not a sphere of chaotic ice, but a body sculpted by symmetry. Its central ridge was angular, segmented like the spine of a colossal instrument. Along its equator, faint, geometric grooves reflected sunlight in perfect intervals, forming hexagonal arrays. These were not cracks from sublimation, not the random scars of collision. They were deliberate, spaced at regular distances, echoing the precision of design. Spectral mapping from the orbiter's instruments detected localized magnetic fields emanating from beneath the surface. Weak but distinct, arranged in alternating polarities as though the structure within was made to channel energy. The data analysis team hesitated to publish, fearing ridicule, but the findings were clear. Atlas possessed order, structure, and internal magnetism unlike any known comet. Its surface, when modeled in 3 dimensions, resembled a shell composed of tessellated panels, many slightly misaligned as if eroded by ages of cosmic wear. The panels were layered, their composition dominated by nickel compounds unknown to earthly metallurgy. The ratio of isotopes suggested refinement, a process of selection impossible in nature. As the first color-enhanced images were released to the public, the reaction was immediate and divided. To some, the object was a miracle of natural geometry, a frozen cathedral built by accident and time. To others, it was the unmistakable fingerprint of design, a relic from a civilization that had mastered the physics of light and energy long before Earth had drawn its first breath. In the months that followed, humanity's imagination ignited. Philosophers wrote that Atlas represented not a visitor, but a memory, a piece of an intelligence that once was, drifting through eternity, waiting to be seen. Engineers studied its energy emissions and speculated that it might be a self-sustaining probe, powered by the conversion of solar radiation into coherent light. Biologists asked whether intelligence could be stored not in circuits or neurons, but in the molecular patterns of exotic alloys, a thinking machine made of mineral rather than flesh. Loeb himself remained measured. In interviews, he refused the word alien, preferring instead technological relic. To him, the mystery of Atlas was not proof of life elsewhere, but proof of possibility, the demonstration that intelligence need not be bound to the living. If we discovered an ancient compass at the bottom of the sea, he said, we would not assume the sea built it. We would infer the existence of someone who once navigated it. Atlas, he suggested, was the compass of the cosmos, still pointing somewhere. As new data emerged, the sense of awe deepened into something closer to reverence. Astronomers began to notice subtle periodicities in the light curves, gentle fluctuations that recurred every 137 days, corresponding exactly to the golden ratio when compared to its rotational period. Whether coincidence or communication, the precision was breathtaking. The beam that had once struck Mars had left a faint but measurable electromagnetic echo, a soft radiation fingerprint now pulsing faintly from the Martian atmosphere. It decayed slowly, too organized to be noise. Some described it as a lingering note, a final harmonic that refused to fade. The scientific community entered a new age of humility. Equations were rewritten, instruments recalibrated. And yet, beyond the mathematics, something quieter settled into human consciousness. The realization that intelligence might not announce itself in words or voices, but in patterns, alignments, and the delicate order hidden in light. Perhaps some said this was how a civilization would speak across eons, using the language of the universe itself. 3A Atlas continued its slow journey, drifting now away from the inner solar system. Its beam never fired again, its surface dimmed, its energy faded, and it returned to being what it had always appeared to be, a frozen wanderer in the dark. But for those who had witnessed its awakening, nothing in the night sky would ever look the same. Every comet, every faint glimmer of light became a question. And somewhere in that question lay the truth that has always haunted humanity. That the cosmos is not silent, only subtle. That perhaps the universe has been speaking all along, and only now have we begun to listen. In the quiet aftermath, observatories continued to track Atlas until it vanished beyond the reach of our instruments. Some predicted it would circle back in several centuries. Others believed it would never return. But the legacy of that event endured, not as proof, but as wonder. It taught us that discovery is not always about answers. Sometimes it is about being confronted with the immensity of not knowing. Future generations will study those 11 minutes of light. They will model the equations, trace the resonance patterns, and try to decode what message, if any, was written in that focused beam across the stars. Perhaps they will find a signal. Perhaps they will find nothing but coincidence wrapped in mystery. But either way, 3A Atlas has already fulfilled its purpose. It reminded humanity that the universe is vast not only in size, but in imagination. As our telescopes gaze outward into the endless dark, we may never again see that strange glimmer that once turned its gaze upon us. Yet its memory endures like a reflection upon a still sea, a reminder that we are participants in a cosmic dialogue older than time itself. One day, perhaps, when we have learned to answer in kind, the stars will speak again. And when they do, it may not be through words, but through the purest language there is, the silent, unbroken beam of light.